conversion of oxide into impure metal, that is smelting and reduction will be involved. The fourth and last one, very important, refining. So one by one we'll discuss. This is the complete outline of the metallurgy chapter what we have in our syllabus. Concentration, we have both physical method and chemical method. Conversion of ore, we have both calcination and by roasting we have. And conversion of metal oxide into impure metal, we have smelting and reduction. Refining, we have different methods for different metals. So let us start the session one by one. The first one is, we have three types of metallurgies. The first one is pyrometallurgy. The name itself, it involves high temperature and it is used for heavy metals like zinc, copper, mercury, tin, etc. And hydrometallurgy, name itself hydro, water, solution is involved. According to electrochemical series, this hydrometallurgy we are going, and generally copper, silver, gold, high SRP metals we can go for hydrometallurgy. And electrometallurgy, electrolysis is involved. First group, second group, and aluminum. Pyro, high temperature, hydro, solution, electro for first group and second group elements, and aluminum. So here in metallurgy, as per the NCERT, few metals like copper, sulfur, gold, and noble gases. Chemistry salt, gold and noble. Carbon, sulfur, gold, and noble gases occur in free in nature, uncombined state. Remaining elements, they exist in combined state in the earth crust. Carbon, sulfur, gold and noble gases occur in free state. Remaining elements available in combined form. So what is mineral form? The simple definition is the combined form of the element. The combined form of the element which is available in earth crust. Sir, what is ore? Ore is a mineral from which metal is extracted profitably, economically. That is about ore. One important statement is there. All ores are minerals, but all minerals are not ores. What is that? We'll discuss later. All ores are minerals, but all minerals are not ores. Here majorly we should talk about one important point, gong. Gong, also we are calling matrix or impurity. Generally ore is contaminates with earthy and undesired materials. We are calling impurity or gong or matrix. So aluminum is the most abundant metal in the earth crust and third most element in the earth crust. Aluminum is major components will be mica and clay. Many gemstones contain impure form of alumina. You can take ruby and sapphire, important. Just now we discussed one statement. All ores are minerals, but all minerals are not ore. So what do you mean by that? For example, if you take aluminium, for aluminium we have different minerals. Here sulfur we have corundum. For example, we have diaspar, we have bauxite, and we have gibbsite. So this is Al2O3, this is Al2O3 H2O, bauxite will be Al2O3 2H2O, gibbsite will be 3H2O. These are minerals, but the ore of aluminum is bauxite. Simply I can say metallurgy is nothing but completely money business. From which mineral we can extract very cheaply, that is called ore. So cinnabar is mercuric sulfide, argentite Ag2S, cerussite lead carbonate, important. Some list of minerals given in NCERT. Please go through that list from NCERT. Next, first step, concentration of the ore. So concentration of the ore. In concentration of the ore, physical method we have. In physical method, gravity separation, hydraulic washing or litigation. Gravity separation, hydraulic washing or litigation. This is applicable for oxides and carbonates. Oxides and carbonates. It is based on specific gravity, difference in specific gravity. So what do you mean by that? When you wash the ore plus gong in the stream of water, gong will be lighter, it will be washed in streaming in the water. So this process we are calling gravity separation or hydraulic washing. So it is based on difference in specific gravity, and oxides and carbonates are purified by using or concentrated by using gravity separation. Next, magnetic separation. Magnetic separation, very important. One of the component must be magnetic in nature. What do you mean by that, sir? Either ore or gong must be magnetic in nature. Used to separate S and P block compounds from transition elements. For example, we have wolframite. Wolframite is a magnetic ore which contain SnO2, tin stone, as a non-magnetic impurity separated by using magnetic separation. Very important, flotation process applicable for sulfide ores. The principle is differential wetting. Here what we are doing is we are taking oil and water. So ore is coated with oil and gong with water. Here three important key points are there. Frothers, pine oil, we are using collector, sodium ethyl xanthate, depressant, sodium cyanide, and stabilizer AC, aniline and cresol. For example, why we have to use a depressant? For example, one ore contain both sulfide ores. For example, PBS and ZnS. But we have to impress someone, we have to purify someone, we have to concentrate someone. So when you want to satisfy one, we have to depress someone. So that is the reason when you treat with sodium cyanide, zinc is a transition element. Therefore, with sodium cyanide, it is forming a complex. We can remove zinc sulfide. From that we can extract PBS, or we can concentrate PBS. Next one, chemical method, that is leaching. Very important. In leaching, aluminium, silver and gold aluminium, silver and gold. In this process, the ore is dissolved in a suitable solvent. In the case of aluminium, we are using sodium hydroxide. When you use sodium hydroxide, we are getting sodium meta-aluminate, NaAlO2. Whereas in the case of, very important question is there. In the case of gold and silver, one important question is there, ma. So I am writing here, in the case of gold or silver, we are using sodium cyanide or potassium cyanide. Whenever you use sodium cyanide or potassium cyanide, so we are getting this complex MCN2 minus. To get pure metal, this is treated with zinc. As a result, we are getting ZnCN4 minus 2 we are getting. So these two complexes are very important. Here metal may be gold or silver. So leaching, for aluminium we are using sodium hydroxide. We are getting sodium meta-aluminate. For gold and silver, sodium cyanide or potassium cyanide we are using. Next step. Second step. Calcination or roasting. That is conversion of ore into oxide. So what do you mean by calcination? The process of heating the ore to very high temperature in absence of air below its melting point. Sir, it is applicable for what? It is applicable for oxides, hydroxides. So when you heat it, it liberates carbon dioxide gas. If any moisture is there, the moisture will be removed. So you can see here, when carbonate is heated, we are getting oxide plus carbon dioxide gas is liberated. When hydroxide is heated, so where water vapor is removed. In this process, very important, the ore releases gases like carbon dioxide and water vapor. That is the reason the ore become porous. Ore become porous and volatile impurities are removed. Next to roasting, definition wise same, but only difference will be in presence of air. Roasting is applicable for sulfide ores. Impurities like sulfur, phosphorus, arsenic is removed in the form of volatile oxides. So here sulfide on roasting is converting into oxide and liberating sulfur dioxide gas. Next, third step, reduction. In reduction, we are getting 95 to 98% of the metal we are getting from the oxide. In reduction, one important question is there, self-reduction. For self-reduction, you remember cup hug. That is copper, lead and mercury. Copper, lead, mercury, cup hugs undergo self-reduction. They acting itself reducing agent. We no need to add any extra reducing agent. Important. Next, what is smelting? In smelting, oxide plus reducing agent plus we are adding flux if required As a result, we are getting metal. So, what is a flux? Flux is used to remove impurities. So, flux to convert non-fusible impurities to fusible one. So, flux may be two types, actually three types. Acidic flux is uses to remove basic impurities. For example, silica I am taking. One important question is there. In the case of copper, iron oxide is impurity. To remove this, we are adding acidic flux. This is flux in copper industry. Generally, gong plus flux will get slag. These slags are aluminates or silicates. Aluminates or silicates. So here we are getting iron silicate. Whereas basic flux is used to remove acidic impurity. For example, CaO. In the case of iron metallurgy, silica is impurity. To remove that, we are adding basic flux. As a result, calcium silicate we are getting in the form of slag. In copper industry, iron silicate. In iron industry, calcium silicate is a slag. Very, very important. So one important question is there, very, very important. Below 710 degrees centigrade, carbon monoxide is best reducing agent. Above 710 degrees centigrade, high temperature, carbon is reducing agent. Why? We are going to discuss in a Lingam diagram. Next, thermite process. Aluminium acts as a reducing agent. So NEET 2022 question. Aluminium acts as a reducing agent. Thermite process. In thermite process, this is very, very important. Iron oxide or chromium oxide 3 ratio and aluminium we are taking 1 ratio. 3:1 ratio of chromium oxide and aluminium we are calling thermite mixture. Next, just now we discussed leaching. In leaching for gold, so we are using this complex, gold and silver, same complex only. Here we have gold, here we have silver, coordination number 2, oxidation state 1. To get pure metal, treated with zinc by getting this complex ZnCN4 minus 2. Next one is refining, very, very important, last step. In refining, physical process, liquefaction. Liquefaction is used for low melting metals like tin, lead, bismuth, antimony. Distillation for low boiling metals, low boiling point metals. Zinc, cadmium, mercury, 2b group elements, volatile metals. Zone refining, fractional crystallization. In this ultra pure metal we are getting silicon, germanium, gallium, etc. So very, very important. In chemical process, first one is cupellation. Silver or gold having lead as impurity is purified by using cupellation. Pooling. Copper and tin, lead having impurity of their own oxide So basimerization is applicable for a copper metallurgy is not purification method. It is used to manufacture steel and cast iron. Finally, thermal decomposition, very important. Van Arachil method, zirconium, titanium, hafnium. When you treat with iodine, we are getting volatile compound, and which is further heating, we are getting pure metal. So Van Arachil method for zirconium, titanium, hafnium. Mond's process applicable for nickel. When you treat nickel with CO, we are getting tetracarbonyl nickel, and heating we are getting pure nickel. So impurity treated with CO, here impurity treated with iodine. So Van Arachil method for zirconium, titanium, hafnium, Mond's process for nickel. Electrolytic refining, anode impure metal, cathode pure metal. For example, in the extraction of copper, impure copper is taken, or silver taken as anode. Pure metal is taken as anode. This is we are taking as anode. Pure metal we are taking as cathode, and electrolyte is its own solution. Maybe copper sulfate, maybe silver nitrate, whatever it is. Finally, aluminium. The ore of aluminium will be bauxite. And one important question is there from NCERT. The pure alumina is a bad conductor. To increase the conductivity and decrease the fusion temperature, we are adding cryolite and fluorospar. Let us discuss this. Very important. So, purified alumina is mixed with, very important, cryolite and fluorospar, which lowers the melting point of the mixture and brings the conductivity, increases conductivity. This sentence from NCERT, very important. Steel vessel with lining of carbon acts as cathode, and graphite rods acting like anode. So you see here molten Al2O3 plus cryolite. On electrolysis, aluminium is obtained at cathode and carbon dioxide is released. One important point is there. Carbon at anode producing both CO and CO2. And one important point from NCERT. For each kg of aluminium, if you take 1 kg of aluminium, during electrolysis, 0.5 kilogram of carbon is burnt. Carbon is consumed. So anode cathode reactions are important. Anode is important. First we are getting carbon monoxide. Second one we are getting carbon dioxide. Finally, in the case of iron, for iron, minerals are important. You remember one shortcut, Siddhu ko, Hema se, love and pair. Sir, what do you mean by this? Siddhu means siderite. Formula FeCO3. Hematite. Hema means hematite. First letter we have to take He, hematite. That is Fe2O3. Next, magnetite. Magnetite is Fe3O4. Love means limonite. Limonite is Fe2O3. 3H2O. Last one pair. Pair is nothing but iron pyrite. So these are the minerals. But what did I say? The ore. Ore is nothing but hematite. So finely divided hematite. On gravity separation we are removing silica. Ore is concentrated and we are subjected to calcination in blast furnace. So in blast furnace we are getting first important point is in blast furnace pig iron is formed. The highly impure form of iron is pig iron. Pig iron contain 4% of the carbon. Very very important. And other we have sulfur, manganese, silica, phosphorus, etc. But carbon is 4%. And when you further molten iron is taken, and further if you do, we are getting first cast iron. From there we are getting wrought iron. Wrought iron is pure form of the iron is wrought iron. Pure form of the iron is wrought iron. It contains 0.2 to 0.5% of carbon. Important. In blast furnace, reactions are important. I am dividing the equations into two categories. The first one is 500 to 800 Kelvin. One important shortcut is there. Fe2O3 will be converted into Fe3O4 and FeO. Fe3O4 converts into iron, but FeO does not convert into iron at low temperature. Very very important. At low temperature. Now at 900 to 1500 Kelvin, FeO with the help of reducing agent, that is CO, we are getting iron. And already we discussed the impurity silica, the flux is CaO, it is removed in the form of calcium silicate. So in blast furnace, the iron we are getting is pig iron. The iron we are getting is pig iron. Important. So this much. This is the outline of the NCERT. Please go through the NCERT. A lingam diagram I will discuss in the next video. Thank you. Please like and subscribe.